What we're going to do today is combine the use of the distance, midpoint, and slope formula with what we learned in Unit 5, all those parallelograms, and we're going to be able to determine what shape we are given in a coordinate plane based off of those characteristics. So what we're going to do first is look at this table right here, and we're going to put an X if the one of these characteristics is true for that shape. So let's start with the parallelogram. So in a parallelogram, the diagonals do bisect each other, but the diagonals are not necessarily congruent, and the diagonals are not perpendicular. So diagonals bisect each other is the only thing that we can for sure determine in a parallelogram. Now, if that parallelogram was a rectangle, well, the diagonals would still bisect each other, but the diagonals are also congruent. So that differentiates the two. But in a rectangle, the diagonals are not perpendicular. For the rhombus, since the rhombus is still a parallelogram, the diagonals bisect each other, but the diagonals are not congruent. However, they are perpendicular. For a square, well, a square has all three of them. A square is a parallelogram, so the diagonals bisect each other. The square is a special type of rectangle, so that means the diagonals are congruent. And the square is also a special type of rhombus, so the diagonals are perpendicular. So then we go to the isosceles trapezoid. Well, the isosceles trapezoid is not a parallelogram, so the diagonals are not congruent. Or sorry, the diagonals are, they do not bisect each other, but in an isosceles trapezoid, the diagonals are congruent, but the diagonals are not perpendicular. And then finally, the kite's not a parallelogram, so the diagonals don't bisect each other. The diagonals are not congruent, but they are perpendicular. So you can see from this table here that each shape has its own characteristics when you look at the diagonals of that shape. Yes, we could look at the side lengths and the slopes of all the sides, but that's going to be more math and more calculations. If we just focus on the diagonals, that will be fewer calculations and we can still get the same answer. All right, so example number 1, we have this quadrilateral, and what we're going to do is we're going to have to find the lengths of the diagonals using the distance formula, the slopes of the diagonals using the slope formula, and then possibly the midpoint of each diagonal if we can't narrow it down. So if we look at this, let's label our diagonals. So I'm going to draw one in red and one in purple. And let's start with the slope. Real quick, I'm going to write my formulas up here in case I forget them. I won't write them down for each step, for each problem, but I'll just write them once up here so that we can refer back to them as needed. So capital M for midpoint. Well, since we're adding, it doesn't matter if it's x1 plus x2 or x2 plus x1. Look at the same thing because the order does not matter for addition. So those are my formulas. So I'm going to do the slope of each line. So the slope of xz, okay, And it doesn't matter which point you label x1, y1, just as long as you're consistent. So x1, y1, x2, y2. Okay, so we'll have 0 minus 4 over 5 minus 3. So that's going to give us negative 4 over 2 or negative 2 over 1. And yes, you could just simplify that and say negative 2, but because we are comparing slopes, and we're looking for opposite reciprocals for perpendicular lines, I'm going to leave it as a fraction. Now we're going to find the slope of WY. So that is going to be 4 minus 0 over 8 minus 0, which is 4 over 8, which equals 1/2. So these two numbers here are opposite reciprocals. If you flip negative 2 over 1 and change the sign, it becomes 1/2. If you flip 1/2 and change the sign, you get negative 2 over 1. So we know that these two lines are perpendicular. So that means that the shape has to either be a rhombus, a square, or a kite. So now let's find the distance of each diagonal. So the distance of xz is equal to, and I'm going to use red, it's going to be 0 minus 4 squared plus 5 minus 3 squared. So I'm going to type that into my calculator. We get 0 minus 4 squared plus 5 minus 3 squared, and that gives us 4.47. Now I'm going to do the same thing for WY. So we'll have 8 minus 0 squared plus 4 minus 0 squared. And I'm going to do that in my calculator over on my phone. And I get 8.94. So the diagonals are not congruent, so that this can't be a square. So this is either a kite or a rhombus. So now we're going to do the midpoint of each diagonal. Okay. So the midpoint of, let me use a different color, dark blue. So the midpoint of xz is equal to, we'll add the two x coordinates, 3 plus 5 over 0, comma, adding the two y coordinates, 4 plus 0 over 2. So that's going to give us 8 over 2, which is 4, comma, 4 plus 0 is 4, divided by 2 is 2. So that is the coordinates of the midpoint of xz. Then we'll do the midpoint of WY. Whoops. Okay, so adding the two x coordinates, 0 plus 8 over 2, comma, adding the two y coordinates, 0 plus 4 over 2. 0 plus 8 is 8, divided by 2 is 4. And 0 plus 4 is 2, or sorry, 0 plus 4 is 4, and 4 divided by 2 is 2. So they have the same midpoint, which means they bisect each other. So when I do the midpoint of the diagonals and we get the same midpoint, that means the diagonals bisect each other. So if we go up here, if the diagonals bisect each other and are perpendicular, it must be a rhombus. So down here, this must be a rhombus. Now we look at example B, and we don't have a picture drawn for us, so we got to plot these points first. You'll notice, though, that the x coordinates, if you look in the x direction, those go up by 2's, but the y axis goes up by 1. So j is going to be at -4, 2, so -4, 2 is right here. And k is at -2, 8. So that's k. L is at 10, 4. 1, 2, 3, 4, 5. So that's really 10, 4. 1, 2, 3, 4. And M is 8, -2. M is right there. Now you may say, well, this is obviously either a rhombus or parallelogram, but because your x coordinates go up by 2, you really don't want to go by the picture. So KM is one diagonal and JL is the other diagonal. So we're going to find the slope, distance, and midpoint of those diagonals and compare them. So the slope of KM, and we can write x1, y1, x2, y2 to help us out. So the slope is going to be -2 minus 8 over 8 minus -2. And that is going to give us -10 over +10, which is -1 over 1. And just like the previous problem, we're going to leave the slope alone so we can compare them. Then we'll do the same thing for the slope, of JL. And I'm going to do a different color so it's easy for me to find them again. Okay, so we're going to do 4 minus 2 over 10 minus -4. So that's going to give us 2 over 14, or 1 over 7. So those are not opposite reciprocals. So what that means is that the diagonals are not perpendicular. So this is going to be an isosceles trapezoid, a rectangle, or a parallelogram. So now let's find the lengths or the distance of each diagonal. So the distance of KM, and I'm going to go back to using my black markers since I labeled my points in black. So the square root of 8 minus -2 squared plus -2 minus 8 squared. So when I type that into the calculator, I get 14.14. All right, so now let's find the distance of JL. And when I do that, I have 10 minus -4 squared plus 4 minus 2 squared. So when I type that in the calculator, I also get 14.14. So that means the diagonals are congruent. All right, so go back up here. The diagonals are congruent. So now we're left between a rectangle and isosceles trapezoid. So then we'll find the midpoint. The midpoint of KM is going to be -2 plus 8 over 2, comma, 8 plus -2 over 2. -2 plus 8 is 6. 6 over 2 is 3. 8 plus -2 is 6. 6 over 2 again is 3. So then we'll do the same thing for JL. So in JL, we have -4 plus 10 over 2, comma, 2 plus 4 over 2. So -4 plus 10 is 6. 6 divided by 2 is 3. 2 plus 4 is 6. 6 over 2 again is 3. So they have the same midpoint, which means that the diagonals bisect each other. So if you remember from our table, if the diagonals bisect each other and the diagonals are congruent, that means we have a rectangle. We're going to skip letter C for now. Now, letter D, I'm going to plot the points, draw the diagonals, and then I'm going to ask you to pause the video and try it on your own, and then unpause it to see if we got the same answer. And I'll have all the work shown out in case you get messed up anywhere, but I want to see what you're able to do before checking your answer. So we'll plot our points, -8, comma 4. Again, look at the x values go up by 2. So -8, comma 4 is right here. 0, comma 6 is right there. 2, comma -2 is right there. And D is -6, comma -4. So right here, kind of off the graph a bit. Oops. Okay. So AC is one of your diagonals, and BD is the other diagonal. So let me just also label these with the corresponding colors, again, to help you out. So go ahead, pause the video, and at the very least, find the slope, the distance, and the midpoint of AC and BD. That should be something you know how to do. And even if you can't classify it, having that is going to get you really close to being able to classify it. So pause the video and find those calculations. All right, so here are my answers for the the slope, distance, and midpoint of my diagonals. So I'm going to leave this here for a second so that you can double check. Your slopes should have been opposite reciprocals. For AC, I got -3 over 5. And for BD, I got +5 over 3. Those are opposite reciprocals. For the distances, or the lengths of each diagonal, I got 11.66, the exact same thing. And then finally, the midpoint of each diagonal, I got the same coordinate, -3, comma 1. So if we look back at the chart on the very first page, you would see that the only shape that has all of these characteristics for the diagonals is a square. So this shape must be a square. So the hard part about this is really going back and forth between that table to figure out what shape you could have. This is more of a tedious thing because you're finding the distance, the slope, and midpoint of all of your diagonals, and then determining what shape it could be based off of that. So the more you practice this, the better you'll get at it. But you really have to be able to go up here and really look at this to determine what shape you have. So Thank you for watching. Make sure you like the video and subscribe.